Hello everyone, this is Akash. Welcome back to this YouTube channel Nursery with Lecture. In this video, I am going to discuss the last chapter, that is applications of derivatives in the differential calculus series. In the change makers by JEE 2023, I already completed so many chapters. That is very important topics, that is sets, relations, mathematical reasonings, limits, continuity, differentiability, methods of differentiation. These are all the topics I completed in a flow. So if you didn't watch those videos, watch those videos also, because those are the one-shot videos, but the quality is very high in that. What are the main topics are present, I explain very detailedly. So if anyone is new to this channel, please watch those videos also, because those videos are really important to you. And also if anyone didn't join the Telegram group, join the Telegram group also, where you can get the access to download the notes of the class, and also to do the practice, I created a Google form and I kept nearly 20 questions in that. So you can practice a lot there. So if anyone didn't join the Telegram group, join the Telegram group. And also in these applications of derivatives chapter, it is very important. Up to now in functions, what you have learned, you will apply here, because this is applications of derivatives. Basically, how to do differentiation you already seen in the previous video, that is methods of differentiation. What are the types of differentiation, how to do differentiation, logarithmic differentiation, successive differentiation, like that, parametric differentiation. So many things I explained in the previous video. So if you didn't watch those video. After watching those video, you can watch this video also, or you can watch this video also, because this video can able to give the basics to you. But for advanced, you have to watch those video, that is methods of differentiation. So you can watch this video. After this video, you can watch that video also. So now let's discuss the applications of the derivatives part. These are all the topics I'm going to cover now, that is tangents and normals, how tangents and normals are created, and how to do the differentiation, that is how to apply the differentiation concept here in the tangents and normals, and also the applications of tangents and normals, how to apply these tangents and normals in the given problem, and also monotonicity, how the function is increasing or decreasing, we will see here, and what is the maximum and minimum value of the function, and first order derivative, the second derivative test, higher derivative test, global maxima, global minima, Rolle's theorem and LMVT, Lagrange's mean value theorem, curvature, inflection of point, rate measure. These are all the topics which are very important to the JEE mains topic. So listen carefully. The first thing is tangents and normals. Tangents and normals. Basically, actually the flow is not like that, but I prepared this in order to give the more insights about the important topics, because in these application of derivatives there are mixture of nearly 6 chapters, that is rate measure, tangents and normals, and monotonicity. Like that, there are different chapters in this chapter. In chapter there are 6 chapters, small chapters, but you have to focus the main thing, that is tangents and normals here. Suppose if you given a function, if examiner given you a function, that is y equal to f of x, you have to find normal and tangent to this at the point x1 comma y1. If they ask like that, you have to differentiate the function. That is, you have to differentiate the function, and you have to keep this point in this, that is f of x1. And when you keep this point, this is a point at where the normal is, this is a point at which they are asking to find the normal and tangent. So we are finding the point, that is point here, and after finding the slope, we can able to make the line, that is tangent and normal. It is very important. ఇక్కడ మనం ఏం చేస్తామంటే, ఫస్ట్ టాంజెంట్స్ అండ్ నార్మల్స్లో మనం ఒక కర్వ్ ఇచ్చి మనకు దాని మీద ఒక టాంజెంట్ వెయ్యండి అని చెప్తే మనం ఒక పాయింట్ ఇస్తారు. మనం ఏం చేస్తాం, ఆ కర్వ్ని డిఫరెన్షియేట్ చేసి మనం ఏం చేస్తామంటే ఆ పాయింట్ని సబ్స్టిట్యూట్ చేసి మనం ఫస్ట్ స్లోప్ తీస్తాం. స్లోప్ తీసిన తర్వాత మనకేం అర్థమవుతుంది, ఆ స్లోప్ అనేది ఈ టాంజెంట్ యొక్క స్లోప్ అనేది, మనం ఎప్పుడైతే టాంజెంట్ యొక్క ఈక్వేషన్ కనుక్కుంటామో ఆ టాంజెంట్ ఈక్వేషన్ నుంచి మనకు నార్మల్ యొక్క స్లోప్ తెలుస్తుంది. ఆ నార్మల్ యొక్క స్లోప్ నుంచి మనం ఏం చేస్తాం, నార్మల్ని కనుక్కుంటాం, నార్మల్ యొక్క ఈక్వేషన్. ఇది బేసిక్గా. అంటే ఇప్పుడు సపోజ్ టాంజెంట్ యొక్క స్లోప్ ఒకవేళ సపోజ్ m అయిందనుకో, నార్మల్ యొక్క స్లోప్ ఏమవుతుంది, -1/m కావాలి కదా, ఎందుకంటే ఈ రెండింటి యొక్క ప్రోడక్ట్ ఏం కావాలి, -1 కావాలి కదా, ఎందుకంటే ఈ రెండు 90 డిగ్రీలో ఇంక్లైన్ అయి ఉంటాయి కదా. సపోజ్ ఇది ఒక టాంజెంట్ అయితే ఇదేంటిది, ఇది నార్మల్, ఇది టాంజెంట్ అయితే ఇది నార్మల్ అవుతుంది. కాబట్టి ఇన్ ఏ కర్వ్, ఇఫ్ ఏ పాయింట్ ఈస్ గివెన్ at which you have to make a normal on tangent, you have to first differentiate the curve and keep the point, and you have to find the slope. After finding the slope, this slope is the tangent slope, and after knowing that they are perpendicular, you can easily say if they are perpendicular, you can assume the slope, that is if m is the slope of tangent, you can assume the slope of the normal, that is minus 1 by m. So like this you have to do the basic understanding of tangent and normal. After this, the applications of tangent normals, where these tangents and normals are applied, that is there are two cases where this is a application. ఎక్కడ మనం అప్లై చేస్తామంటే tangents and normals టూ కేసెస్లో అప్లై చేస్తాం. ఒకటి కర్వ్స్ మధ్యలో యాంగిల్ కనుక్కోవడానికి, యాంగిల్ బిట్వీన్ టూ కర్వ్స్. సెకండ్ ఇది ఏంటంటే డిస్టెన్స్ బిట్వీన్, షార్టెస్ట్ డిస్టెన్స్ కనుక్కోవడానికి కర్వ్స్ మధ్యలో, షార్టెస్ట్ డిస్టెన్స్ బిట్వీన్ ద కర్వ్స్. ఈ రెండు కనుక్కోవడానికి మనం ఏం చేస్తామంటే టాంజెంట్స్ అండ్ నార్మల్స్ యొక్క అప్లికేషన్ చేస్తాం. ఇప్పుడు ఫస్ట్ దాంట్లో ఏంటంటే యాంగిల్ ఎలా కనుక్కుంటారు? ఇప్పుడు సపోజ్ ఇది టూ కర్వ్స్ అనుకోండి, ఈ విధంగా ఇంటర్సెక్ట్ అయ్యాయి. మనం ఈ రెండింటి మధ్యలో యాంగిల్ కనుక్కోవాలంటే మనం ఏం చేస్తాం, ఈ పాయింట్ ఆఫ్ కాంటాక్ట్ ఉందా, ఈ రెండు కలిసాయి, దానిపైన టాంజెంట్ వేస్తాం, దీనికి టాంజెంట్ వేస్తాం. టాంజెంట్ వేసి దాని మధ్యలో ఉన్న యాంగిల్ కనుక్కుంటే చాలు కదా. అదే కదా యాంగిల్ బిట్వీన్ ద కర్వ్స్, యాంగిల్ బిట్వీన్ ద కర్వ్స్. ఇదే అర్థమైందా? ఇప్పుడు ఈ యాంగిల్ అనుకోవాలంటే మనం ఏం చేయాలి, ఫస్ట్ కర్వ్ని డిఫరెన్షియేట్ చేయాలి, తర్వాత సెకండ్ కర్వ్ని డిఫరెన్షియేట్ చేయాలి, అప్పుడు ఈ పాయింట్ ఆఫ్ కాంటాక్ట్ని పెట్టాలి. ఫస్ట్ చేయాల్సిన పని చెప్తాను చూడండి. యూ హ్యావ్ టు ఫస్ట్ ఫైండ్ ద పాయింట్ ఆఫ్ ఇంటర్సెక్షన్ ఫర్ దీస్ టూ కర్వ్స్, అండ్ ఆఫ్టర్ ఫైండింగ్ ద పాయింట్ ఆఫ్ ఇంటర్సెక్షన్ యూ హ్యావ్ టు డిఫరెన్షియేట్ ఈచ్ కర్వ్ and keep that point of intersection. After keeping the point of intersection, you will get the slope of two lines, that is slope 1, that is m1, slope 2, that is m2. If you get these 2 points, that is these two values, you can use the formula of tan theta, that is mod m1 minus m2 divided by 1 plus m1 m2, where you can find the inclination of curves. Inclination of curves. These m1 and m2 are the slopes of curves at point of intersection of curves. These minute things are very important in this chapter. And now you got the idea how to find the angle. Now let's discuss the shortest distance. Suppose these are the two curves. Suppose assume the distance between two curves is, you have to, if you want the shortest distance between these two curves, the shortest distance is lying along their common normal. It is the very important thing. The coordinate geometry also explained in very detail. If you want the distance between the two curves least, that is less, that is the shortest distance, you have to draw a normal common to both the curves. When you draw a normal common to both the curves, then there you will get the shortest distance. This is the thing, and I will explain a problem in this problem in the next session, that is after completing the topic I will explain the problem also. Wait for that. And next, now let's discuss the first topic is completed. Now let's discuss the monotonicity. What is monotonicity? Monotonicity. The meaning of monotonicity is, the function is, suppose if you draw any function, the function may be like this, the function may be like this. What is the meaning of this? ఇక్కడ మనం నీట్గా గమనిస్తే ఏంటంటే, ఇక్కడ ఈ పాయింట్ తర్వాత ఈ పాయింట్, సపోజ్ ఈ టీటా అనేది ఇంక్లినేషన్ అనుకోండి, ఈ ఎఫ్ డాష్, సపోజ్ ఎఫ్ ఆఫ్ ఎక్స్ అనేది ఈ ఫంక్షన్ అనుకోండి, ఎఫ్ డాష్ ఎక్స్ ఇక్కడ చేస్తే ఇది పాజిటివ్, ఇక్కడ డిక్రీజింగ్ కదా, ఇది ఎఫ్ డాష్ ఎక్స్ ఇక్కడ నెగిటివ్. అంటే మనకి ఒక ఫంక్షన్ ఇచ్చి అది ఇంక్రీజింగ్గా డిక్రీజింగ్గా ఒక పాయింట్ దగ్గర చెప్పామంటే మనం ఏం చేయాలంటే, మనం ఫస్ట్ ఆ ఫంక్షన్ని డిఫరెన్షియేట్ చేయాలి. డిఫరెన్షియేట్ చేసి వాళ్ళు ఇచ్చిన పాయింట్ పెట్టాలి. ఆ పాయింట్ పెట్టిన తర్వాత ఒకవేళ అది కానీ పాజిటివ్ వచ్చిందంటే ఆ ఫంక్షన్ ఇంక్రీజింగ్, ఒకవేళ ఆ పాయింట్ కానీ పెట్టిన తర్వాత అది కానీ ఫంక్షన్ లెస్ దాన్ 0 వచ్చిందంటే ఆ ఫంక్షన్ డిక్రీజింగ్. ఈ విధంగా ఇదేంది, ఇది ఇంక్రీజింగ్, ఇది ఇంక్రీజింగ్, ఇదేంది, ఇది డిక్రీజింగ్. ఇప్పుడు ఐడియా వచ్చింది కదా, ఇంక్రీజింగ్ డిక్రీజింగ్ ఈ రెండు. దీంతో మొనోటానిసిటీ అయిపోయింది. మొనోటానిసిటీలో ఇంకా టాపిక్స్ ఉన్నాయి, చెప్తాం. నెక్స్ట్ ఏంటంటే మ్యాక్సిమం మినిమా. maxima and minima. Minima. What is maximum? The meaning of maximum is maximum. That is, if this is a curve, like this, if you take the points, there is a minimum and there is a maximum. The meaning of this is, in a curve, the highest point is called maximum and the lowest point is called minimum. You have to understand this. And in that also, there will be a local maximum, local minimum. That is, the reason is, there are two things, that is local maximum and local minimum. Normally you can say that in this graph the highest point is this and the lowest point is this. So this is the maximum, this is the minimum, you can say. But if they ask in a particular interval, suppose this is the interval they asked. In this, suppose the graph is like this. Like this the graph is. Suppose in this interval there are two local minimas, but the local minima is this. Understand? There might be so many minimas outside this interval. Outside this interval, this is the overall, this is the minima. But if you see this interval, this is the minima, not this. This is the minima. So you have to understand one thing, that if they ask in an interval, you have to check the interval at the starting points, that is closed points, as well as in the middle. It is very important. And next, the first derivative test. First derivative test. First derivative test. What does first derivative test mean? The first derivative test gives the idea how the function is behaving, whether it is increasing or decreasing, at what point it is getting the maxima, at what point it is getting the minima. These are all the things we will get from the first derivative test. Suppose if there is a function x square plus 2x plus 1 equal to 0. Suppose this is a function. I want to know about the behavior of this function. So I will differentiate, that is 2x plus 2 equal to 0, x equal to minus 1. X equal to minus 1, I am keeping this thing. If x equal to minus 1, that is 1, minus 2 plus 1. So the answer is 0. So f dash x is 0. You have to conclude one thing. F dash x greater than 0, increasing curve. F dash x less than 0, decreasing curve. F dash x 0 means neither increase nor decreasing, that is f dash x 0, that is slope 0. Slope 0 means, suppose if we draw this x square plus 2x plus 1 in a graph, you will get what are the points here? Minus 1 is a 1 point, and again minus 2 x square, this is x plus 1 whole square, that is minus 1 and minus 1 is the points. You can see that here minus 1 and minus 1, this is a curve for this. If you observe clearly, at the point, that is at the point of 1, that is minus 1, the f of x is 0. You are clearly visible here. This is f dash x. F dash x is 0 here. Means this is a point where you will get the minimum. Maximum is infinity. There is no discussion. Minimum is 0. Minimum is 1. At the point of 1, you will get in the minimum. This is the thing. So these are all the things you will get from the first derivative test. So the first derivative test, you can see how the function is behaving, increasing, decreasing, local minima, local maxima. These are all things you will get. Now, this is the first order derivative. There will be a second order derivative also. Second order derivative test. After completing the first derivative test completion. First derivative test completion, we will go to the second order derivative. What does second order derivative gives us? Second order derivative gives us suppose if we do the differentiation, that is f dash x, if we do in the first derivative test, if we get 4 a, b, c 4 points, a, b, c, d 4 points. Now we have to say among these a, b, c, d, at what point the function is getting the minimum, maxima. For that you have to do the double derivative test, that is second order derivative test. For this, if double order derivative, that is f double dash of, suppose if there is a, if we take a point f double dash a, and if we take this is greater than 0, that is this is a minima point, that implies that is minima point. So what we can infer in this, that is at point A you are getting the minima. It is very important, understand? If we do the first derivative test and we got the 4 critical points, basically at what points the f dash x is 0, those are called as critical points. Suppose in the previous example, that is 2x plus 1, 2x plus 2 equal to 0, x equal to minus 1. This point x equal to minus 1 at where f dash x equal to 0 is called as critical point. It is very important. Now we have to check like this. Here we got only one critical point. Suppose if we got 4 critical points and we have to decide at what point the minima is coming, at what point the maximum is coming, we have to do the double derivative test. If double derivative test of a is greater than 0, that is minima point, and double dash x of a equal to 0 and double dash x of a less than 0. If it is less than 0, it is maxima point, and it is equal to 0. And if it is equal to 0, then second order derivative test fails and we go to higher order derivative test. If it is equal to 0, that test fails. But there is no need of second derivative, third derivative, fourth derivative, nth derivative test. There is no need. But if you know in advance, there might be some questions where you have to do the second derivative test and higher order derivative test. So you have to learn a little bit. And now we are discussing the higher order derivative test. Higher derivative test. Higher derivative test. Basically, this is higher derivative test is nothing but nth derivative. Means you are differentiating the function n times. So basically in this thing we get four main things, that is if n belongs to even and f of n of a greater than 0 at x equal to a, we get minima. And second, if n belongs to even and f of this is less than 0 at x equal to a, we get maxima. And third, n belongs to odd and f of a greater than 0 at x equal to 0, we get point of inflection. I will explain each and everything, don't worry. These are the important things. If you miss, it will be very difficult for you. See, basically the higher order derivative test is used when second order derivative test is fails. The main purpose of this is you are checking about the inflection, curvature, these things you are checking here. How, suppose if you take this example, suppose there is a point A, before the point it is plus, after the point it is minus, means first the graph is increase and next graph is decrease. So at A we can get maxima. Suppose if there is like this situation, first the graph decrease and next graph increase. What we can say? The reverse of this. First the graph decrease and next graph increase. So we will get minima here. But when you see this case, that is when both before A and after A you will get positive, means the point of inflection. Point of inflection, the curvature will come. So for these curvatures we are discussing here. If we do the nth derivative test and we got, suppose n is even, there are two cases here. If we take n is even, two cases, and n is odd, two cases. For n is even, we get minima and maxima points. What we get minima? Suppose f of n of a greater than 0, we get what? we get minima here. But in the second order derivative test, what we got? If f double dash of A is greater than 0, we got minima. Important here. We got minima. F double dash A greater than 0, minima. Here also minima. And next, if n is even and f power n, that is, what does it mean? It is a higher order derivative test and n is belongs to even and it is less than 0, we got maxima. These two things is clear for you. But when we come to this, if n is odd and f power n times derivation of A greater than 0 at x equal to A, we got point of inflection and f of x is increasing. That is, when this nth derivative of A greater than 0, when it comes, the meaning of this is we got a point of inflection and the function f of x is increasing function. And next, and when this nth derivative test is less than 0 at x equal to A, we get point of inflection and the function is decreasing. So basically 4 things you have to remember. The first is the nth derivative test is used when the second derivative test is fails. In this nth derivative test, there are 2 types. That is, if n is even, n is odd, and if n is even, you got minima, maxima. At f n times derivative of A greater than 0, minima you will get, and if n times the derivative of A is less than 0, you will get maxima. And also, if n belongs to odd, there are 2 cases. That is, if n times derivative of A is less than, that is, if n times derivative of A is greater than 0 means you will get increasing and point of inflection. And if n times derivative of A is less than 0, you will get decreasing function. You can easily remember these things. And now, where is the duster? So this is a thing, complete higher order derivative test. And now let's discuss the global maxima and global minima. Global maxima and global minima. I have already drawn a graph. That is, like this I have drawn some graph. If we observe these points, what you will get the conclusion? The lowest point is here. So this is a global minima. Globally, what is the minimum value? This is. And at globally, what is the maximum value? This is. Global maxima. Suppose if you take this interval, this is minima. And if we take this interval, this is minima and this is maxima. Like that, depending on the interval, we are deciding. But overall, if we decide, if overall function, what is the highest point and what is the lowest point, that is, what is a global maxima, what is a global minima, you have to see at the end points as well as at the middle. It is very important. And next, let's discuss the Rolle's theorem and LMVT. This Rolle's theorem and LMVT is very important. Basically, those are the statements. If you learn the statements also, it is more than enough. Rolle's theorem and LMVT. Suppose they are saying that if f of x is a function, see, f of x is a function. F of x is a function and a comma b belongs to R. This is a statement. You have to learn the statement also. What they are saying, suppose there is a function like this. This is a point A, this is a point B. Suppose this is a function. What they are saying, first point, f of x is continuous in the closed A comma B. F of x is continuous in closed A comma B. And second, f of x is differentiable in open A comma B. Second point is clear. It is continuous as well as differentiable in closed open A comma B in this thing. And next, third thing, if these two conditions is satisfied, and next third condition is f of A equal to f of B. If these condition also satisfies, then there exists a point C such that f dash C equal to 0. they are saying that in between A and B, there might be a point where f dash c, that is the derivative, might be 0. They are saying like that. It is very important. Then there exists at least one value of c, at least. More than one values also it can exist, but at least one value of c will exist in between A and B, where the f dash x will be 0. Understand? This is main thing. The main condition is here. F dash c equal to 0 and f of a equal to f of b. This is the main thing. This is Rolle's theorem. And next, that is Lagrange's mean value theorem, LMVT. Same. The main thing is f of x is a real function and a comma b belongs to R. This is completely same. And next, f of x is continuous. This is also same. F of x is continuous, that is a comma b, closed a comma b. And next, second, f of x is differentiable. F of x is differentiable in open a comma b. It is also condition is satisfied. Then they are saying there are two conditions only, and what they are saying, then there exists a, suppose this is a, this is b. If you take this is a, this is b, what they are saying, then there exists at least one c value such that f dash c equal to f of b minus f of b divided by b minus a. This is a slope. Actually, this is a point, this is a b point. If you see the quadrants of this is a comma f of a. If you can see this quadrant, this is b comma f of b. Basically the slope, basically this is a slope. If we take f of b minus f of a divided by b minus a, this is a slope. This slope is equal to the slope of that point f of dash c. This is a main condition for Lagrange's mean value theorem. You have to understand f dash c equal to f of b minus f of a divided by f dash c equal to f of b minus f of a divided by b minus a. This is a condition for Lagrange's mean value theorem. What about the Rolle's theorem? In Rolle's theorem, f of a equal to f of b, that is the condition, and f dash c equal to 0 there. It is very important. There might be exist, might not. It should exist at least one c value in between a and b, where f dash c equal to 0 in Rolle's theorem. But in Lagrange's mean value theorem, there will be at least one point where f dash c equal to f of b minus f of a divided by b minus a. Basically, it is a slope. We are saying the slope is equal to slope. It is true. And now let's discuss the curvature and inflection point. Curvature and inflection point. So basically in the lower classes you already learned. Suppose if it is a mirror, this inside, what is this? Concave. What is this? Convex. You already know these things. So let's discuss this thing. When you will get concave in the graph and when you will get a convex in the graph. I already explained to you. Suppose if you take a point A, if there is a function, if there is the value positive in the left side, complete positive. If there is a negative in the right side, the graph is first increase and then decrease. If you observe this thing, what is this? This is convex. So like this, the condition is plus minus. You have to alternate plus minus. If you will get the convex upward. And now when you get minus and plus, reverse. Suppose if you take point A, if you take like this, first decrease graph and next increase graph. So this is convex, not this is concave. So this is convex and this is concave. You have to understand one thing. When will be a convex and when will be a concave? The convex is when the first is plus and second is minus, and when it is concave, the first is minus and second is plus. So here in convex you will get the maximum value and in concave you will get the minimum value. In concave you will get the minimum value and in convex you will get the maximum value. This is a thing you have to understand here. This is basically the convex and inflection point here. And next, at what point function changes its sign is called inflection point. Suppose if we take an example of x cube, this is the function, graph is like this. At what point it is changing the curve, that is sign? Up to now it is negative, but next it is increasing. It is increasing graph. So at this is negative, this is positive. You will see this is a point of inflection. It is called point of inflection. And now at last topic, that is rate measure. You have to understand one thing, the rate is always with respect to time. Whether it is given here anything, there is no bother. You have to understand the rate is always with respect to time. Whether it is dv by dt or da by dt or d capital AD by dt, d next what? Area, volume, suppose dp by dt, anything with respect to time only, rate measure. So I will be discussing one problem in this rate measure, so you will get an idea. So basically the chapter is completed, applications of derivatives is completed, and now let's discuss some of the problems in this chapter. Some of the problems in this chapter where you can understand how these derivatives are applicable in the solving problems. See here, there are two parabolas. One equation is y square equal to x minus 2 and another is x square equal to 4y minus 2. What they are asking is you have to find the shortest distance between them. If you draw the line like this, and if you take any parametric point here, that is what parameter you can take? You can take parameter as, suppose it is x minus 2. How to make the perfect square with this? You have to take the parameter. How can you take the parameter? That is a question. You can take 2 plus t square na? If you substitute 2 plus t square, you will get t, that is x 2 plus t square, and next y as t. This is a parametric coordinate, and also this, if it is a parametric coordinate and this is a line, if you draw the normal like this to this line, this is the equation of minus 1, slope is 1. This it has to be slope minus 1. Understand? And also y equal to x. If we do here x2 plus t square comma t, this is y square equal to x minus 2. Now we are equating the slope. We have to differentiate the thing, that is 2y equal to 1. 2y equal to 1, and y, what is the y? T. Means 2t equal to 1, t equal to half. When you substitute t equal to half, what will you get here? You will get 9 by 4 here, and you will get 1 by 2 here. So basically 9 by 4 comma 1 by 2 is the point, and we are dropping, we have to find the length. These two lengths are equal. Suppose if you take x, this is x, so basically we have to find 2x length. But what about the x length? It is a perpendicular drop from 9 comma 4 to 1 comma 2 to the line y equal to x. So x minus y equal to 0 is a line, and the perpendicular we are dropping is 9 by 4 comma 1 by 2. So what will you get the distance? That is 9 by 4 minus half divided by root 2. Root 2 na? 9 minus 2 divided by 4 root 2 means 7 by 4 root 2 you will get. This is a distance from here to here, but we have to find complete distance. So basically these distance is equal, so we are multiplying into 2. What will you get? That is 7 by 2 root 2. This 7 by 2 root 2 is a distance, shortest distance between two parabolas. This you have to understand. And next, the rate measure. I said I will explain. There is a lamp post and there is a man. This man is moving away from the lamp and its shadow is falling here. The man shadow is falling here. Suppose if we assume the length of the shadow is L and the man height they given as 1.6 and they given the lamppost height, that is 4. Suppose if we take this as x, you can clearly observe what they are asking. They are asking how fast the man shadow lengths. This is man shadow lengths. They are asking DL with respect to time. At what they are asking with respect to time, how the length of the shadow is moving. They are asking. You can clearly visible that there are two right angle triangles here. And if we observe, that is 4 by complete triangle 4 by x plus L. If we compare with this, the relation is like this. And when we solve, basically this is 16 by 10 na? That is 10L na? So when we 40L equal to 16x plus 16L. So what you will get? You will get 24L equal to 16, correct only, 4 by x plus L equal to 10, 16 by 10L. Okay. 40L equal to 16x plus 16L. What you will get? 24L equal to 16x. Means 4 4s are 4 6s are 2 2s are 2 3s are. Means L equal to 2x by 3. What they want? DL by dt na? DL by dt. DL by dt. L equal to 2x by 3. So what they are asking? Above the ground, how fast the man is moving. So basically, L equal to 2x by 3. You have to find dl by dt. We have to differentiate this. dl by dt equal to 2 by 3 into dx by dt. They given dx by dt. At how much speed it is moving? That is 30 meters they given. So basically 30. 3 ones are 3 tens are. So basically the man shadow is lengthening. That is the length of the shadow is increasing at the rate of 20 meters per minute. 20 meters per minute. It is very important. So basically this is the thing. And also if you observe, I will discuss another question, that is, if you take root 101, there is a principle in the differentiability. I already explained to you. That is, the principle is f of x plus h equal to h into f dash x. I already explained f of x plus h equal to f of x plus h h into f dash x. I already explained. We have to find root of 101. How can we find? It is basically 100 plus 1 na? So basically this is a root x is a function and 1 is a h. That is the error. So when we do that, if we take the root x as a function, that f of x is nothing but root x plus h into h is nothing but 1 into f dash x is nothing but 1 by 2 root x. So basically we are keeping 10 here. That is root 100 plus root of 100 plus 1 by 2 root 100. That is 10 plus 1 by 20. What will be the answer? 201 divided by 20. That is 10.05. 10.05 is the square root. That is 10.05. Like this you have to do. Basically this is the thing. This is the thing, and the chapter is completed. I hope you understand the chapter. There is only the new thing is the global maximum, minima and the derivative test. There is nothing more than that. The remaining all the things are you already studied in the functions chapter. So that is for this video, and if you like this video, subscribe to this channel and also hit the bell icon, and please join the Telegram group to access the notes as well as the problems given by me to you in the Telegram channel. It is very important to do that problems, because those problems are the PYQ questions which are really have the probability to come in your exam also. Directly not, indirectly, but they can change the values, but there is a probability. If you get 2-3 questions also, it is more than enough. So do the problems correctly. If you have any queries, please drop a message in the comments box. I will answer the message to you. I will reply to you, and also if any new sessions you want, please inform to me. I will bring that sessions also. Thank you.